Hello, everyone. My name is K. Praveen Kumar Reddy. I'm working as assistant professor at RMD Engineering College, Chennai. In this video, I would like to discuss about a serial communication protocol, which is named as SPI. The name SPI stands for Serial Peripheral Interface. So what is this SPI standard, SPI protocol? Is whenever you see some electronic PCB board or something like Arduino, you will see some pins named as some pins of the microprocessor or PCB pins named as shown in the figure in the slide, where the names will be given as MISO, MOSI, and SCK and SS. So whenever we see these kind of names, we have to understand that this board or processor supports the SPI protocol, that is Serial Peripheral Interface Protocol. So what is SPI is, as it is a protocol for serial communication, the data has to be transferred from one device to another device serially. That is, one device can be a master or transmitter, transmitting device, which we can call it as master. Other device will be the receiving device, transmitting and receiving. We can call them as master and slave. So these pins are named like this, where this MISO and MOSI is nothing but master input, slave out. That is, when I show you one picture, so when we assume like we have two ICs where some data has to transfer from one device to another device, one IC to another IC. So we name them as master and slave. Okay, where the names can be interchanged, vice versa. So when I say, you can see on the screen, it is written as MOSI. That is master out, slave in. That is, master is sending the data output and slave is taking it in. That is, master is the sender, transmitter, and the slave is the receiver. Master out, slave in. And similarly, there is another pin named as MISO, master in, slave out. That is, slave is sending the data and master is receiving. So both bidirectional transfer can be done using this protocol. So two lines are dedicated, one for one way and another for the return path, the return way. So bidirectionally, we can transmit the data from master to slave or slave to master. And what is this SCLK is serial clock. That means that whenever we transmit some data between two devices, those two devices should operate in synchronism. That is, the transmitting speed and receiving speed should be the same. That is, for example, if master is transmitting the data at 1 megahertz, slave also should receive the data, should be capable of receiving the data at 1 megahertz speed. So the speed of transmission or receiving should be matched. So in order to make sure that will happen, the clock pulse is commonly shared between the master and slave. So if master is operating on 1 megahertz, the slave also will receive the same clock pulses, that is 1 megahertz. And both should work in synchronism. And the fourth pin is meant for uh, slave select, SS or CS. Slave select or chip select. SS means slave select or chip select. Here in this slide, we see only one master and one slave. So first, whenever before transmitting some data from master to slave, that particular slave should be activated. Once the slave is ready, only the data has to be transferred. So to select that particular slave and activate it, this signal is used, chip select or slave select. Why this thing is, In different cases, we may have multiple slaves, not only one single slave. We may have multiple slaves as shown below this slide. So in this slide, if you see, we have one master and three slaves. So we can observe in the picture, we have S clock, serial clock going commonly to all the devices. Serial clock is going to slave 1 and slave 2 and slave 3. Same clock. So all the slaves are synchronized with master, the same frequency. And master out, slave in is also going commonly to all. So only one thing the difference between the previous diagram and here is we have here, because there are three slave devices, I should require three pins for selecting the particular slave. So here SS1 is nothing but slave select 1. SS1 bar means it's a negative logic. So when you make this line active, this line is going to SS bar. That is, this slave 1 will get activated. That is, if I write a 0 on this SS1, the slave 1 will be selected. If I want to activate slave 2 and transmit some data, I have to make this SS2 pin as 0, that is SS2 bar, negative logic. So if I make this line active, slave 2 will be selected. If I make SS3 as active line, this thing will be selected. So at any point of time, I have to activate only one slave, so that the data from master should go to that particular slave. That means that before transmitting the data, we should decide which slave device, to which receiving device the data has to go. That is done by choosing this slave select pins or chip select pins. So the disadvantage here is, here this SPI protocol, here in this picture we have only three devices. So for n number of devices, we require n number of slave select pins. In this case, we have three devices. Three devices requires three different pins to select them: SS1, SS2, SS3. If you think of n number of devices, you will have n number of pins on the master. So as you go more, as you increase the number of peripherals, that is slaves, as n increases linearly, the number of pins also on the master processor also increases linearly depending on the number of slaves. So having more number of pins on master is a disadvantage. That is, on a processor or master device is not a good thing. Generally, in nowadays technologies, we may connect some hundreds of peripherals to one master device, one processor. So one processor may be managing some 100 peripheral devices. So if you think in that scenario, 100 devices require 100 dedicated pins to select them. Like 100 devices in the sense, you can think like 100 peripherals like EEPROM, printer, scanner, pen drive, a lot of peripheral devices we have to our computers. So as the n number of peripherals increases, the number of pins also increases. So this is a disadvantage of the SPI protocol. Okay. So as you can see here, the same picture in another format, PS1. So as you can see in this picture, we have four slaves. So I require four pins: CS1, chip select 1, chip select 2, and chip select 3, and chip select 4. As the number increases, this number of pins also increases. Here we have four devices, four pins. So like that, it goes on. So this SPI protocol is used only where we have very less number of peripherals, like such as inside the motherboard or inside on the motherboards, where the devices are very nearby. Okay, some few devices, less than 10 or something, few peripherals are connected, not more than that. So the remedy for this is we have to go for the other kind of protocols like I2C, inter-integrated circuit, and other like CAN protocols. To overcome this problem, they have developed some other protocols like I2C. which we will discuss in the further discussion. So thank you very much for your listening. I will stop here. Thank you.